We have a dilution refrigerator, and this base plate right here is what gets a fraction above absolute zero. Orders of magnitude colder than space.
All of this machinery exists just to cool down the computer chip, the processor.
So inside of this specially engineered box, we have a quantum processor, it's a solid-state quantum processor. On this chip, there are 4 qubits, and the qubits themselves are what are performing the calculation.
Classical computers use data in the form of bits, each a 0 or a 1. But quantum bits, called qubits, use the feature of quantum physics that means things can be in 2 places at once. It can be a 0 and a 1, and everything in between, all at the same time. This gives it the power to do many calculations simultaneously.
And we mount this quantum processor onto the base plate here, and we then make all of these electrical connections. And then we're able to move the quantum information all around that chip and then actually extract the answer. From a scientist's point of view, it's a very exciting tool that we could probe nature.
It's so fast that it could be the kind of computer that finally cracks RSA encryption. To prove it, in principle, Eric used his computer to find the 2 prime numbers making up a small semi-prime.
And so it's sort of at the level of technology that I would say is maybe like an Atari, right? It's kind of 8-bit technology. And it was a very kind of neat toy problem, and that we've tried to find, using a quantum processor, the factors of 15. And I'll let everyone kind of think about that for a minute, but that is probably something that we all can do even in grade school. And it took me 7 years to get my physics PhD to do that with a quantum processor.
What's remarkable is not the answer, but the way the computer does it. The quantum chip considers every possible solution all at the same time, instead of sequentially.
And you're collapsing to this one answer that will actually be the answer you're after, right? Which is a huge speed up, that you kind of explore all of these possible places and possible answers, and you get the one that you want. And we learn, yes indeed, 15 equals 3 times 5.
Eric's proved that quantum computing has the potential to smash the codes that protect the internet.
It blows the doors off of RSA encryption, right? All we need is more and more qubits. We just need a larger quantum computer. Really, all that's left to do is to scale up this particular architecture. It's a big task, and there's a lot of very bright people that are all working towards that. And I think that what's exciting is it really puts kind of a milestone in the ground about where things are and kind of what we need to do next.
You do realize you've broken the internet now?
Oh, yeah, I'm sorry about that.